Great, thanks. Hi, everybody. Appreciate you sharing the time with us today. My name is Craig Mueller. I'm the Vice President of our public sector business here at iboss. With me today is Bill Rhodes. Bill is our Senior Solutions Engineer. Comes to us from a number of different companies in the network security space. Joining him as well as Marc Pergolizzi. Marc's our Vice President of Sales Engineering at iboss. So we appreciate the opportunity to share a little bit about iboss, who we are, kind of where we fit in the zero trust paradigm. If I can figure out how to forward my slides. Here's what we're going to talk today. So I want to spend just a little bit about iboss, who we are, make sure people know kind of where we came from, where we fit into the zero trust ecosystem, some of the architectural differentiation that we think is important for our federal customers, talk a little bit about NIST 853 mapping, what our licensing model looks like. I got about 13 slides that I'm going to go through. For some of you that know me, I recognize some names on the invite. I'll try to be as brief as possible. Brevity is not one of my strong suits, but probably take 20 minutes or so talking a little bit about the first 5 bullet points, and then I'm going to hand it over to Bill and Marc to go through the demonstration. Hopefully, we'll have a few minutes for Q&A. So if people want to, just call out or please put questions in the chat. We'll look to get those answered, and then we'll adjourn. So about iboss, I first heard about iboss. My last job was I ran our public sector business at FireEye, and we had a technical partnership with them, and we provide secure connectivity, from anywhere. So it's a zero trust platform that's connecting, users to any resource from any location. The company is 10 plus years old. We've got a very mature cloud service, cloud native. If you take a look on the right, it says 150 billion transactions a day that are running through the service. That's more than, the number of Google searches, 230 plus patents. We've got over 4,000 global customers, and we've got customers in the top 3 different verticals, financial services, government, higher ed, DoD, automation, life insurance, et cetera. So a lot of people didn't hear about iboss because until 2021, we didn't really have what I would call an enterprise go-to-market function. And that's what I came here to do, is to help build out that public sector organization. I like this slide. It's super busy, but I think with the fact that I think there's 53 different different vendors that are here presenting at, in the zero trust working group. There's a lot of different pieces of the puzzle, right? So as you can see, the way that we look at kind of where we fit in this zero trust ecosystem, kind of try to do it like, gold, silver, bronze. So the gold is a core capability, silver is a secondary, bronze is some, and then blue is limited or no. And the one thing that's important, I think, from a zero trust perspective, is having an open platform that's API driven, that's published, so you can facilitate integration with a variety of use cases. So, obviously if you look at device and endpoint or user, we've got integrations with, and the ability to interact with, all sorts of devices, as well as ID management platforms, right? But if you look at, under user ABAC, like we don't really do anything, in the ABAC space. So this is kind of where we see ourselves. Happy to dig in deeper. If you had the opportunity to look at the vendor profile questionnaire that we answered, we go into each of these, in more detail. So folks have looked at 802-207. You'll recognize this as figure 2. Figure 1 is the bottom part of this, right? And it talks about zero trust access. So at its most simplistic, we're essentially, you have a subject on a system in an untrusted zone trying to access a enterprise resource that's in a trusted zone through a policy enforcement point. And that's what iboss is. We're the PEP. So you can see, we've essentially, and we'll get into the architecture a little bit in more detail later, but you've got your control plane and your data plane. And at the top end, you've got your policy engine, your policy administrator making that decision. And then, do I grant or deny access to this resource based on all of these inputs, right? And those inputs are, threat intelligence systems, identity platform is part of it, right? All those feed your trust algorithm, which we run as part of the PEP to make that decision, connect or deny based on your policy. Here's just a logical architecture. So if you look at kind of the solution prerequisite on the bottom left, as I mentioned, you've got a user, and we're going to integrate with any of the leading, identity management platforms. And then it doesn't matter to us. We're device agnostic, location aware, meaning we can have different policies for geolocation, and such. And then we go ahead and we'll connect users, right, through this middle box here that you see, which is our cloud native security service. All right, so global policy administration, all of these microservices that you see on the left, proxy, secure web gateway, DLP, firewall, IPS, CASB, et cetera. All of those legacy systems that you usually have in your data center, we've put them together in one unified platform, cloud native from scratch, one code base, which allows us to, rapidly innovate because we're not concerned with, multiple operating systems or multiple GUIs or multiple policy engines. Another important thing here is if you take a look over to the right, you'll see these little cubes. Those cubes represent software containerized gateways. And this is really the secret sauce of our architecture. What those containerized gateways do is they isolate each customer's traffic. So you can actually see here, I've got a few different logos that are represented with keys above them. And those keys represent the fact that, customer agency A, agency B, agency C that could be in our FedRAMP service, we completely isolate the traffic. We never mix encryption keys. We never mix traffic. So we alleviate the concern of any type of lateral movement that could take place when you have, what we'll get to in a few minutes, a shared gateway model. So the nice thing about the iboss architecture from my perspective, and one of the things that drew me over here, as the government was moving towards zero trust, is really the ability to isolate traffic, the ability to ensure that, any other customer's traffic can't get mixed with yours. And it doesn't impact availability and user experience and those types of things. And as you see at the top of this, it doesn't matter to us where the resource is located that someone is trying to access. It could be, a SaaS platform like a Salesforce or Office 365. Could be the open internet to go browse for whatever the need is. Could be an agency public cloud. So, whether it's the agency VPC or some things in Azure, or it could be a private cloud, right? Within your local data center. So we've got all these microservices, including private access, which is really, we'll talk about a VPN replacement here in some upcoming slides. But the ability to have all of your TIC 3.0 use cases, as well as your VPN replacement, to move towards a true zero trust model. One more thing I do want to mention here that I forgot is where it says local point of presence. The architecture lends itself to a true hybrid cloud. So if you have use cases, let's say for IoT, where you want to go ahead and put the same physical hardware that we run in our cloud service, into a local point of presence for an IoT use case, or a use case where perhaps you've got remote offices, we can essentially extend and flex the cloud service into the environment, and you've got global policy across the entire enterprise, which I think is important as people start looking towards modernization and they start thinking about retiring their legacy security tools and moving towards a true zero trust model. This slide is a little busy. I won't deny it, but I think it's important if you think about IP restrictions and the need for dedicated IPs to really meet the needs of the idea of 800.207 and the implicit trust zone. And it's interesting, the federal government's been thinking like this for a long time in the idea of an implicit trust zone. And it says, to allow the PEP to be as specific as possible, the implicit trust zone must be as small as possible. And if you think about the idea of restricted IPs to a certain application, the government's been doing that for ages, right? And everybody's in the office. I've got my legacy data center. I have to, go ahead and I'm only going to grant access, from my IP space to my IP space. And that's the only way anybody can get to this, application. Well, that becomes a little bit more difficult when you start thinking about moving people to the cloud, when you start thinking about people that are no longer in the office and they're remote. How do I actually get people from, their house to an application that's in the cloud if I've restricted IPs? What I would ask people to do as they're kind of trying to solve this problem, because it's not that people can't do it. It's what does it actually take architecturally? What do my data paths look like? What do those network flows look like to actually, solve this problem? From an iboss perspective, it's a piece of cake. It's a product of our architecture because we're essentially, because we're essentially isolating all those traffic. So each of those customers have their own dedicated infrastructure. So very similar today on how they do network management, how they do security. It's not a black box, right? They get to see source, destination, and it's theirs. They can put their arms around it, even though it's in the cloud service. We're going to allow them to have their own IPs. They can bring their own, or we assign them to it. So it's a super easy way for, you getting traffic from one location to the next location through IP restrictions. When you have a shared gateway model, the biggest challenge that others face that are in this, secure service edge or SASE or zero trust connectivity, whatever we want to call the space as it's emerging, the challenge that many of them have is that everything's going to a centralized gateway. And when you have a centralized gateway, traffic is mixed, encryption keys are mixed, right? When we're thinking of zero trust, we're trying to reduce the attack surface, right? In the iboss architecture, if customer B is compromised, they can't get over. There's no lateral movement to customer A. In this architecture, you're not sure if you can or you can't, right? All the traffic's actually being missed, so that you're talking about additional risk. And because you're essentially using a block of shared IPs, you also can't determine whether or not somebody from another organization can accidentally get into your environment. So, like I said, solving this problem isn't easy. And what I would ask all the folks that are on the government side to do is just really dig into the architecture, the environment, understand how this works. There's ways to do certain things in cloud services, like, tenant restrictions, let's say in Microsoft, that you turn on extra security for a reason. Just because you're moving to a cloud service doesn't mean that you should give up security. I think with remote work, with things like BYOD, with the pervasiveness of moving things to the cloud, it's super important that you start to think about things where enterprise resources should not be reachable without accessing a PEP. It's imperative that you look at how these technologies work, what the architectures are, and that people can't bypass, because otherwise we're just kind of, moving the problem that we're trying to solve. It's zero trust. It's not like 3% trust. So I would just encourage everybody to really dig into that. We talked a little bit about the container native architecture. So if you think about how things are done today, right, everybody's backhauling traffic from remote locations through a VPN. Security policies are implied. Then I go to the open internet, I go to my public applications. With iboss, like I said, we have the ability to go ahead and have a true hybrid architecture. So you can use our FedRAMP authorized cloud service in conjunction with on-premise, hardware. It's the same exact platform, completely integrated, and essentially global policy across the entire piece of it. So as agencies think to modernize, or they look to modernize and they look to deploy this architecture, it's very flexible we essentially allow you to onboard wherever you want in your modernization journey. And then in the future, some agencies might have everything in the cloud and they'll move their entire security stack to the cloud, right? But I think in many cases, I mean, I'm old. I've been around with data center consolidation days, and there's data centers everywhere still. So I think a very flexible, open platform architecture that allows people to kind of pick and choose where they need to start, and then how they need to move forward will lend itself to a lot of flexibility. VPN replacement, a lot of people are looking at doing that as their first step to zero trust. We can obviously replace the VPN. I talked earlier about private access as rest of the security microservices being in our platform. So if this is a use case that you want to start with, great, we can replace your VPN tomorrow. Or, depending on what your preference is we like to also propose the idea of secure split tunneling. And what we call secure split tunneling is a bad word, right? Is to actually take your remote traffic, run it through those tick controls, and then allow people to go to the internet, to cloud applications as step one, and then a step two, replace your VPN eventually. Then you've got, you're essentially, in my opinion, you're reducing your MPLS costs. You're really taking the risk out of a VPN replacement project, depending on how complex your architecture is. So you have the ability to kind of crawl, walk, run. I'm going to turn it over real quick to either Bill or Marc, just to talk a couple minutes. This is just a notional architecture, but you can kind of, you kind of see our cloud service in the middle, and I'll let these guys talk about it for a couple minutes. Then we'll finish with a couple slides, and I'll turn it over to Bill.
Quick question, if possible. Can you go back one slide?
Yeah.
How are you handling X509 cert off?
Sure. Bill or Marc, you want to, can I ask who asked the question?
Oh, Greg Yost, DISA, Chief Engineer for Mobility.
Thanks, Greg. Bill, do you or Marc want to answer the X509 cert off question, please?
Yep, sorry. So performing client certificate inside of the instance, or as an administrator? Are we talking about from a user's position?
Well, our current VPNs, we have to use our NIPR CAC with a PIN number to authenticate the VPN connection to the concentrator. Mm-hmm. Because our certs get sent to the concentrator, then it gets confirmed against a CDP. So how are you handling, if you're going to replace the VPNs, how are you going to be able to execute that same type of authentication with the CDPs?
Yeah, currently the notional architecture, what we're doing is we institute a posture checking functionality where we're validating the presence of a client certificate on the originating remote device. From that, we're extracting the username, adding it into our statistical interface, and we're actually pulling down information, characteristical information about the user to make other necessary decisions, is AV enabled, firewalling, etc. But we can capture all of that data within our interface. We're not actually taking any of the creds and passing it on to a federated server at this moment in time. Over.
Okay. Because if you're getting into, because you had earlier slides where you were talking about a private cloud,
Correct.
then the issue then is how do you do auth to that private cloud source? And that's where I don't think this falls down.
Yeah, from a private cloud perspective, so that would be an on-premise, but possibly joined to our cloud service. We can integrate with other federated services on-premise or cloud-based for that matter.
Okay.
Hey, Greg, what we can do if you'd like, we can shoot you a note after the presentation, maybe look to schedule a half an hour next week or the week after and kind of dig into this in a little more detail.
That's fine. I was just curious. Thank you so much.
Sure. No, I appreciate the question.
Hey, Greg, I'm just going to pipe in for 1 second. This is Matt Venditto, and I support our DoD customer base. And we've had some conversations with this within the DoD and DISA in particular. And our chief product officer would be a good person if you do have those 30 minutes to bring on there, because we're working through some of these complexities in the DoD right now. So getting some extra perspective and a conversation going between the two of you would be a good follow-up if you're willing.
Super. Thanks, Matt. Okay. Bill, Mark, you guys want to just kind of touch on the architecture for a few minutes, and then we'll finish the slide part of the presentation up?
Sure. So this, what we're depicting here in this notional architecture is a few of the things that Craig had mentioned earlier. This is a single pass type architecture where we have all of the services available, the microservices on the right-hand side, everything from the SSL decrypt all the way down to RBI. So the flexibility of offering not just the services, but also connectivity options. We have the remote users on the left-hand side, regardless if it's a coffee shop or home office. They're TLS connected in through the cloud service using TLS 1.3. Our remote facility cloud joined capability is where we're actually performing a hybrid type model, joining the on-premise private cloud capabilities in with our cloud service, offering a single pane of glass of configuration, not just in the cloud, but also synchronizing the policies and configuration to an on-premise type facility. So extending the vision and policy enforcement of our cloud down to the edge at a remote facility. The remote transport and citizen transport type user, we can have an IPsec tunnel incorporated into this design as well for extending services, whether it be down to a branch office or on the top left-hand corner to private application services. So we can actually attach via IPsec or GRE or via the native protocol. I'm sure that coming through our service that you'd want to have as much security as possible, but offering the ability to go native via native protocol instead of an IPsec is an option that we offer right out from the gate. So the cloud or on-premise services, we're mentioning, that it is a containerized architecture. We give you the ability to do true multi-tenancy, so you can unjoin multiple aspects of our containers and dedicate those resources towards other customers or sub-customers. The horizontal scaling and clustering built into our architecture, we do give the ability to extend these containers based on the capacity requirements set forth by the customer. From an IIS and SASS type capability, we can invoke numerous controls to be able to allow, deny, or force users in a certain operation to allow them to go to different types of services, whether it be a public service or a private service.
Super. Thanks, Bill.
Sure. Thanks, Craig.
Yeah, I'm not going to go through these. This will be part of our follow-up if anybody wants to access this presentation, but I'll just hit a few key things. As I mentioned earlier, because we essentially have the notion of a security edge. you can do on-demand packet capture for troubleshooting, for incident response needs, you know, with other services that's often difficult. The platform's native IPv6, so we're dual homed IPv4, IPv6. So as people start to look at the requirements in OMBM 2107 and moving towards an IPv6 enabled network, that's already there. One of the things I am really excited about is we're coming out with FIPS 199 data tagging. So to be able to actually understand kind of, you know, where is my data and what are these requests in my environment? Like what's being accessed? Are they, you know, low, medium, high systems, which I think is going to not only provide some additional visibility from a security perspective, but really help with compliance and reporting, and it's going to be even more critically important, I think, is, you know, as enterprise assets are everywhere. They're no longer in the data center, right? People are accessing resources that are in multiple different locations. So to actually understand kind of what those requests look like, what resources are being, you know, asked, what those types of requests are, I think it's just going to provide a ton of additional visibility. And as I, you know, mentioned earlier, just you know, an open API driven platform for, you know, maximum integration flexibility depending on your use cases. NIST 853 mapping, one of the things that you know, Jerry, Karen asked was, hey, can you guys provide mapping? And I think pretty much every vendor was like, are you kidding me? Like, you know how much work that is? Fortunately, we did it as part of our FedRAMP authorization. So we actually have that, all that mapping done. So if anybody is interested, you just ask and we're happy to get that to you. From a FedRAMP perspective, we're currently in process for moderate authorization. We actually had our security assessment review meeting last week with our sponsor. They approved everything. We're literally waiting for the authorizing official just to sign the documentation. We expect that to be done within the next few days. Then it'll go over to the FedRAMP office. They take about 2 weeks to actually process the paperwork and then grant the authorization. So it's imminent, sometime in February. And once again, if you're actually interested in the package, you know, our security package, it's available on GSA Max now. And I'm happy to put people in touch with the folks at GSA to get that access. It's up there. We also have the service overlay mapping for the TIC 3.0 guidance completed, and once again, that's available on request as well. Last but not least, our licensing model. So it's a capacity-based model. It's not per user or a la carte. It includes all those security microservices. So I think what it really does is it enables, you know, maximum flexibility and a phased approach to implementing zero trust architecture and modernization initiatives. So happy to share more details with that as well. But that's it. I'm gonna stop sharing my screen and thank everybody for the first half an hour, and I'm gonna go ahead and turn it over to Bill.
Excellent. Thank you, Craig. I appreciate it. Let me just share my screen out. Just give me a second here. Can you see my screen?
We can.
Right. So, right. So the demonstration scenarios that we're going to cover are articulated in some documentation that we've received regarding this. This is a requirements and also part of the ATARC demonstration scenarios. But just a little bit about the interface today. This is the single pass inspection type capability within our interface, where all of our capabilities are found in one place. There's no two clouds or more clouds. There's one instance to provide not just standard internet type browsing, but also capabilities to institute private access or a zero trust type configuration. It's a very intuitive interface. You can actually come over to the right-hand side here and do a search for something of interest, and it'll jump you to the necessary area. Like this is creating tunnels within our dashboard, within our configuration. A couple of things worth noting, just like Craig mentioned, we're based on a containerized architecture. So your assets are found under this area called node collection management, where we provide all of the nodes that are functional in your environment. These two circles are our gateway capabilities. The little graph here signifies our reporting capabilities. And the last three is our RBI nodes, or remote browser isolation. And we're going to cover that as part of the first scenario. But before I move on to that, these are the dedicated IP addresses and not shared IP addresses with any other customer that are assigned directly to the customer. So if you need to do some sort of IP filter security constructs like an ACL to a web service, you can indicate that, through our private access capability that you might be sourced from, say, this one particular IP address versus an IP address or IP addresses that are shared with many of your closest government agencies. We also offer you the ability within our cloud offering to be part of a mandatory release level, optional or early access capabilities. And we give you the ability to schedule when your maintenance window should be. We don't force it upon you to have this particular cloud service updated when we feel like it is important, but more when it falls in line with the schedule of the customer. Right, we provide a cloud health functionality, identifying all of the nodes within the architecture for the customer. This isn't just the entire our entire install base. So we're measuring not just load and device counts, but also responsiveness based on requests from a user to a service. We're a full RBAC controlled type architecture. So our RBAC capabilities give you capabilities to identify a user on the fly, give them full rights, read only. We identify when they were last logged in. We could also time exactly when that particular administrator requires to be moved off out of the architecture from an administrative standpoint. But moving through the interface, we offer release notes, alerts, and advisories from the same interface, so you don't have to, move and transition off to a support portal to get that data.
Bill, let us know when I know you're going to show a few more things around the interface, and then just let me know when you're ready, and we'll kind of go through the scenarios.
Okay. So we design the architecture based on security policies, and the security policies are assigned to basically OUs that are imported into the system so that they can be brought in through some federated service. And from a global standpoint, we can identify all the necessary groups found within the architecture, and the system is intelligent enough to assist you in designing a lot of these security policies based on the different microservices. Like, for instance, maybe private access, you only want employees or the default group for certain access, or the web content filtering controls might be different from an admin group versus an incident response group versus civil liberties or human resources, whatever the case may be. So navigating back through the interface before we jump further down into it, I'm going to take it back to Craig to read off the individual use cases of interest, and then I'll demonstrate how we would configure the interface to accommodate some of those needs. Over.
Okay, great. Thanks, Bill. So yeah, as I mentioned, we're providing zero trust connectivity. So for us, device agnostic, location aware. As Bill said, we integrate with identity providers. So first scenario, got an agency employee working remotely using a personally owned device who regularly accesses a public cloud-based agency app. They access the system as a standard user, but occasionally switch it to administrator mode to perform some system maintenance. The user's physical location changes frequently with personal travel. So what you'll see, there's a few different ways we can approach this use case depending on what the agency's preference is. So I'll turn it over to Bill to kind of walk through how we would address that scenario.
Excellent, Craig. Thank you. In this situation with a remote user, personally owned device, or BYOD, the problem is that a lot of remote users, especially personally controlled devices, that they don't want to load a client present on their system. So what we have is we're in a situation where the customer doesn't want the client, which typically gives a little better level of visibility and control. Other solutions out there provide reverse web proxy type capability, which if you take a look at reverse web proxy, there's a lot of moving parts to it. You have to offer, create a DNS resolution back to the services instance. You have to load a client certificate. You have to enter into policy, and just a numerous amount of heavy lifting. And what we took a slightly different approach, because these are BYOD type devices or untrusted devices, but a trusted user. We're utilizing a capability found within our remote browser isolation piece, right? RBI, or web browser isolation, depending upon how you want to phrase it, because every vendor does it, mentions it as something a little bit different. We've taken the RBI capability and we give you three different modes of operation. The first one is to integrate RBI into a forward proxy type configuration for suspicious or unknown type of websites. That's the easy piece. We do that every day, twice on Sunday. The RBI components for a guest access or BYOD, we utilize two concepts. The first one is called guest access, and the other one is called cloud application isolation. And within the capabilities here, we have the two areas here, and the difference between guest sessions and cloud app isolation. The cloud app isolation offers integration with single sign-on capabilities. So if you're logging into Okta, as one of your tile applications, what we can actually do is take the token that's been identified with your user, and that can be passed on as a single sign-on capability into the backend application, like ServiceNow, Salesforce.com, and whatever offers the backend capability for a single sign-on. The guest sessions, we're going to give you a little bit different capability. The first one is a direct instance for that particular session defined to an application. So I can actually come in here, add a guest application, give it a name, right? We'll just call it something, and then you would have to put in the session target URL, right? So, just for sake, we're not going to save this, but we can identify the capabilities of this guest session to a security group. So we can either say, put it to a default group or a group of our choosing. We have default timers to identify timeout for inactivity. The default branding and content settings are also configurable, where we can offer an intro page, a logo, defined page title information, things of that nature. The file settings capability also allows you to control upload and download functionality, right? So downloads enabled in the session, download of files allowed, or selecting different file types, whether it be the ones that are down here pre-configured or defining your own. And also the upload capability, just because it's browser isolation, by pixelating the interface of the website, we can actually identify different types of files that you would allow for the said application. And just as an example, we have a couple that we've defined in here. So everybody, I'm sure, is familiar with the sharing website called Box. It would be identified with this session URL, so you can populate this to this particular link to your remote user using their device. And we're totally agnostic to browser types. And I can actually come here and run the actual link itself. We get this this pop-up here of that indicating that you're going to be in a browser session, isolated browser session, and then it pops up the interface and allows you to log in and manipulate the site just like if you were going there natively. The however part is this here indicates that that this is an isolated browser session, and if you were to download content, you can view the available downloads before it comes to your actual browser or your workstation. You can actually take a look at what's found in there. So we could just pop out of here and close the session. And the convenience here is that that was without authentication, and we can modify guest access to integrate with SAML. We could also incur a passphrase or no authentication on a per application basis. The other thing that's of interest, let's just say you have a mix and match of different applications down here. We could also institute a dashboard. You could provide this to your users. So if I were to copy the dashboard, come back over here, pop the link in there, and what it's going to do is populate my screen with the available options that we saw in the previous configuration screen without having to share out each individual link if we didn't have to. So we could just jump in here, just like we did before. We're coming through the browser isolation session, and it populates the screen just like it did before. All right, coming back in through the interface here. The great thing is in our solution is that we have reporting and analytics even for these BYOD type use cases. So if you had SAML integrated, what you'd get here is the conversation of the actual user itself and everything that has been that's flown through our remote browser isolation or guest access. Including full SSL decrypt. It exposes the content to data loss prevention and malware detection. Our CASB capability for identifying applications, and all of it is populated and stored within the reporting capabilities in our real-time log, which can also be sent over to a SIM tool of your choosing or a cloud architecture via CISA. That's it for scenario number one. So, sorry about going on a little bit too far with this, Craig.
It's all right, Bill. We won't hold it against you. All right, scenario number two, we've got a government employee working from an agency satellite office on GFE. They access internet sites, site support between job-related research as well as personal banking, and the agency has a limited personal use policy. So Bill's going to go ahead and kind of show you, the underpinnings of our policy engine and how that can be easily modified.
Excellent, Craig. Thank you. So AUPs or acceptable use policy, they can extend above and beyond just a certain list of allow and block lists. And what we offer for an acceptable use policy is tightly coupled integration with the user itself, and especially if this is a GFE device, we would be utilizing our cloud connector technology, which is a small form factor agent that is resident on a GFE device. The different operating systems that we support for our cloud connector is Windows, Windows terminal servers, Mac OS, Linux, Android, iOS, and Chromebook operating systems. So what this buys you is the flexibility to integrate an AUP on different types of endpoints. When you pull down one of these images, which you have a lot of instructional information in here, you can also tie it to a set of connector policies. And one of the questions that was asked earlier about, ensuring that certain aspects of the configuration of a user is present before it establishes connection into our service. We have this concept of device posture checks where we can identify firewall settings, disk encryption, whether or not the device is joined, anti-malware, whether that's enabled, and also the capability to institute a client certificate check for that endpoint itself, taking a look at the certificate store of the end device and actually making a decision before it actually connects. So in this particular case, client certificate check, in this imposed configuration, we're telling it to reject the registration or access into our environment. We could also manipulate a couple of other things. So every time that the cloud connector comes in through our cloud service, we do this concept of a registration. It's just a double check of, hey, what, who is this? What's your configuration, your posture check information? What group are you part of? What names can we pull off from the via the client connector? But we could also enable other capabilities like updating IPs, applications, etc. We can also create a tunnel port range. So, people might look at our solution and say, oh, that's just a proxy. It's going to be 80 and 443. Well, and here, just like anybody else, I can set, a configuration to allow, everything in the 65,535 port range. The cloud connector actually downloads the trusted man in the middle to the trusted certificate store of the end client. So once we extract all this information and pull it via registration, it's loaded on the machine via SCCM, Intune, or you could do a manual install of the MSI. But the capability that you get is visibility into who's connecting into your environment. And our users, groups, and devices break out the different device types, the versioning of the actual cloud connector itself. But what's pretty important down here is visibility into the actual users themselves. So I can identify a particular user and I can double click on any one of these and it'll give me information, not just about what you see here, but a plethora of information. Like say, this guy, Drew Galinas, he's associated with this FanDuel demo, desktop application, and three other private access type applications. We can also take a look at some of the other settings that are identified with his particular client. And we're actually pulling off of his machine, not just his username, what security group he's tied to, but in other information like the last time he had requested registration, his MAC address, his actual MAC address, the device ID, his IP address, some other components that are relative to the environment. So if going back to, I believe it's scenario 11 for compromised credentials, you can actually come over here on the right-hand side and click on revoke device access. So doing that can actually disable access for that particular user into the environment. So if all of a sudden your IDP organization comes back and says, this guy's password was revoked. It was hacked. I can actually come in here and revoke the actual device itself, and then I can enable it for in the future if it was false. I could also select how far back I could take a look at inactive devices. But getting back onto the position of an acceptable use policy, we start off over in the web security area. And using the different microservices that are available here, I can actually come down and provide content filtering as part of the acceptable use policy. And just like with anything else, allowing or denying access to certain sites is easy. But from one page, we're giving you soft override, stealth capability, prioritization of one group or one category over another, but also deciding what's going to be SSL decrypted. Like, for instance, for finance, you might want to have that particular category identified as do not decrypt because it might be sensitive information because your legal organization has identified that to be something that one should not decrypt for sensitive reasons, applied to that particular customer. I could actually jump down in the same area. I could work on evasive protocols and say, don't allow Tor and some of the other evasive protocols listed in there. Browser and OS deprecation or controls. For those older versions of browsers, we can actually take a look at the request from the user coming through the cloud connector and then block or only allow certain type of browser types. The same thing applies for the operating system down here. So whether it be an older version of operating system or just something that's not sanctioned in your environment. As part of all of our different areas of interest here to configure, we could assign it also to different groups. So like I mentioned earlier, one group might have a higher precedence of what they can access versus others. And that could be configured in this particular realm here. And I could inherit the configuration from one group or another, or I can save a configuration in this area to other groups. So if I'm only working in the default group and I want to modify or make the same changes over here into the employees group as well, I could do so just by moving it over in this area.
Hey, Bill, because I know we're kind of pressed for time. I appreciate that. As everybody can see, very robust policy engine based on least privilege. You can get super granular to, take your zero trust controls to extremely limited. So we'll go to scenario 3. Contracted employee provides improvements to an agency system as part of a development team, et cetera, et cetera. Development is performed on a separate network, isolated from the production network. Both operate within a data center located with the agency's facilities. When appropriate, the contracted employee moves systems from development environment to production. So this in scenario 4 to us, like we said earlier, we're location aware and device agnostic. So it doesn't matter to us if it's, the systems are in the cloud or if they're in a private data center or any combination. So really the Bill's going to kind of walk through tenant restrictions and some policies around VLANs that actually address scenario 3 that we're on now as well as scenario 4. Bill?
Yeah, this is that tricky area, Craig, right? There's a lot to be seen in the details, right?
Sure.
If the development and production systems are to be isolated architectures and you don't want the same containerized to be, or the solution to be used for development and production, we also have the ability to come into our node collection management capability. And in here, these 2 nodes here are part of a group. So if you wanted to make this one, say, production and this one development, I can actually come into the node group and I could start separating excuse me, not the wrong one. I can actually separate these 2 nodes and make them totally independent. So in one instance, a user can be coming in through possibly a cloud connector, or even if you wanted to use RBI, we can isolate these individual nodes and identify them for whatever service that's required.
So I'm actually doing network segmentation inside of my cloud service.
Exactly. So the other area is to, if the deployment is on premise, we also have different VLANs that we can assign different policy rules to, as well as local subnets. So that these 2 subnets can signify 2 different areas of interest, one production, the other one for for development, and then write our policies based on the destination organization. Over.
Super, thanks. All right, so scenario 5, similar to what we just talked about, really for us, scenario 5 talks about an agency system interfacing with another agency system, accessing fingerprint information. 6, it talks about both system or public clouds. 6, talks about the data center. 7 through 9, it's essentially the same scenario, right? It's just, we're just switching things around. Once again, for us, it doesn't really matter where those resources are located. So Bill's going to kind of get into the policies and how that would work. So Bill.
Yeah, so depending on, but there's a couple of moving parts to this as well, Craig. So depending upon the who, where they're coming from, what type of device it is, where they're going, there's a couple of philosophies that we could institute here. Depending upon the sensitivity of the application, you can actually come into RBI and use guest access or the cloud app isolation and identify via the session list an individual destination, whether it be cloud-based or it could be in an agency's data center. To identify the particular, it doesn't have to be a cloud connected type device, like I said, coming through the RBI. This is a totally unsanctioned other device and not so much, a trust of the same agency going to the same agency server. It's 2 totally different agencies. So RBI is one methodology of doing this functionality. The other one is utilizing private access. So our private access capability institutes the functionality of integrating a federated service like SAML to identify the user and then applying a policy to them. So you would create a policy, a private access destination, which could be an IP address, an entire subnet, a URL, and this could be a public or it could be an internal URL or domain. The policy sets things in order, right? So I can actually come into the policy section here and link an individual user, their group, or even dynamic GeoIP linking and say, I'll only allow Bill Rhodes and then part of, let's just say, the employees group, right? And he's got to be coming from, a CONUS location. So I could click on that and then apply the policy for that particular instance accessing that particular service. Does that make sense, Craig?
That makes sense to me, Bill. So what I think we wanted to highlight here is extreme flexibility, very restrictive, multiple different ways to essentially connect from, resource to resource, depending on what the trust level of that relationship is and, for a variety of use cases. Anything else you want to cover in this scenario, Bill, before we go to scenario 10? We got about 15 minutes left.
No, but that'll be, we're good here.
Okay, great. So this one we can all probably, unfortunately, relate to. Remote users on an agency's cloud-based high-value asset system are having connectivity issues, inconsistently kicking them off their session. Outline any tools you provide for administrators troubleshooting. Like Bill said, I think one of the real neat things about iboss is, even though this is a cloud-based service, the look and the feel, because we're isolating each agency's traffic, the look and the feel of what the cloud service is with iboss is very similar to how they're doing, network administration today. So Bill?
Sure, thanks, Greg. So we're going to first go down memory lane here of reporting and analytics. So our solution offers reporting within the cloud service or on-prem. So we have two capabilities in that area there. And we have a sizing model to introduce capacity storage for the sizing model of the customer's interest. We can actually also export or forward logs to SIM tools. So So in this particular case, we have a configuration for Splunk. We have other service types such as syslog, FTP, etc. We could articulate the log types, whether it be URL and or IPS, continuous transfer intervals, or you can set a timer, different field delimiters. One organization might use space based on their sim or comma or tab type separated. So it's not just sending to one location. I can actually add a service for other locations as well of interest, right? So use different types of protocols. I could articulate the different types of URL fields that are going to be found in the environment, add it over. And let's just say this particular field I want first. I can actually move it up into the rule set to say this is what's going to occur first in the logging capability. So from a real-time troubleshooting capability, I can come into real-time dashboard. I can take a look at the different widgets here to take a look at trends, liability, overall bandwidth, but come down to real-time logging. I can view the logs generated in this format, and I can actually do a search in real time. So let's see, do I have any logs in here, right? So if I just put my first last name in there, it comes up with the logs associated with me that are of recent time. So I have my timestamp here, my actual source IP address, the type of category, action, whether or not malware was detected, and I can change the architecture of the dashboard and how it looks. So if I want to take a look at destination IPs, which node, iboss node it's coming from, I could actually enable that on the fly, and it would provide me with that level of detail. So the next one is PCAP. So everybody, has a methodology of struggling with packet captures, right? A lot of times, since the shared models offer other vendors, other adjacent customers traffic, but we do it a little bit differently because you own your own containers. These are your assets. We institute the diagnostic capability to actually come in and perform a packet capture on whatever set interface that you define. And I could put in a filter, let's just say it's IP based, and a duration of time. And then once I come in here and I hit capture, it automatically downloads a PCAP file to my workstation. So this becomes a very unique methodology for assisting and troubleshooting user environments. So the logging is one, the PCAP is another. With the actual cloud connector, if you are using our application, the iboss cloud connector, we have different diagnostics that we can identify with that particular user, such as the private IP address space that they may have come from, their agent type, the different types of PAC scripts that may be invoked, SAML login pages. And like I showed you earlier, is the ability to bypass certain subnets or applications. A lot of that is found within this screen as well. I could also jump down and identify recent connections. So this gives me a lot of information of the connection from my actual cloud connector client itself into said application via what particular gateway. Over.
Super, thanks, Bill. So as you guys can see, a lot of rich information to help with troubleshooting. And like I said, very similar to the way people are doing it today. So as you move your security to the cloud with iboss, you're not giving up any of that visibility and you keep that control. Scenario 11, Bill, you touched on a little bit earlier, the ICAM administrator has reported a user's credentials were compromised. Describe any tools, methods you provide to validate unauthorized access, has not occurred either on premise or cloud-based. So you want to talk a little bit about, kind of looking at the logs again, revoking the user. I think that'll just be a couple minutes and then we'll kind of go to agency 12 and look to wrap up.
So once again, taking a look at real-time logs, or we can take a look at, longer stored log information. identify who they are, where they're coming from. Highly filterable log event methodology here. What type of logs that we're taking a look, that we be looking at, the device name, username, whatever the case may be. And then getting back to the actual cloud connected devices themselves, I can actually pull right over here. This is one of my other accounts. I can actually come over here and sit and revoke the user and do my investigation post haste instead of waiting for the user, waiting for somebody to reach out to the user and physically identify them.
So the ICAM administrator contacts the network team, bang, you revoke your user, and then the incident response team starts to look at all the logs and go through their process. Perfect. Scenario 12, an agency's decided to perform penetration testing exercises against their HVA systems operating under the ZTA umbrella, both on-premise and cloud-based. Describe the tools, methods you provide or support to accommodate these penetration testing exercises. So we'll talk a little bit about like how we can accommodate those, as well as, how our security helps, stop attacks, if you could.
Yeah, so as I read this particular scenario, an HVA, a high value asset system, is something that potentially is perceived as national security type assets, right? If any information or data is leaked, that it could have irrecoverable type situations. And the way we look at it is that it's answered in a couple of different lights. The first one is, as Craig had mentioned, our PEP or policy enforcement point and our is all evolved around a unique architecture utilizing the minimization of the last mile between our solution and the service. So we're reducing the size of that particular that implicit trust zone. That's number one. Number two, utilizing capabilities like private access, bringing in policies and tying it very closely to SAML to only allow certain users based on the policy set. We were actually controlling the limitation of access based on the user, geolocation, and also the group that they may be part of. The direct attacks against our private access space by utilizing the implicit trust zone, utilizing restrictions of IPs and ACLs by the end application. So beyond that, our capability to bring in other functionality like intrusion prevention systems, we as a entire solution, we offer you two subscriptions. One's through VRT and the other one is through ET Open, where over 22,000 possible IPS rules are available at your disposal. And these can either be set to monitor, disable, or block certain threats based on categories, or you can actually jump down to the rule. I would say one of the most current ones that are of interest is Log4j, right? Log4j. And if I just do a simple search like this, it will bring up all of the emerging threat signatures that are associated with that particular threat. And I can come in and I can edit each individual one of these IPS signatures and also associate email alerting with each and every one of them. Next, to help protect the system. Again, this is a pen tester trying to attack or do the pen test against a zero trust umbrella, right? So the end application. So we're going to protect it in a couple of different ways. IPS was one. Malware defense is going to be another. So I could institute a bunch of rules identifying, in this particular case, I have this rule here that could be assigned to post, gets, puts, and deletes, but also network sources, users, groups, target destinations. So that target destination can be an IP address of the remote destination, different types of content types. And this is 600 different types of applications that we actually take a look at, that we can actually perform a function. So at the end of the day, setting a malware rule, we can block threats that are being pushed to the end application. And all of this comes up as a reported incident inside of our event logging capability for clarity to incident responders. Device posture checking was another one that could be of interest, right? To ensure that a system has not been compromised, I can come over to the connect devices, take a look at the connection policies, and ensure that the desktop applications, all of them have, posture checking set where, they have their firewall enabled, disk encryption, AV enabled, and possibly client certificates as well to ensure that the position and posture of that particular user satisfies the needs of access into the environment. Let's see.
Super. So we've got about 5 minutes left. Thank you, Bill. I don't know if there are any additional questions that any of the folks have, but as we said, there's a lot of flexibility, control, visibility with this platform, extremely granular, policy-based administration and global policy throughout the environment, regardless of the architecture, whether that's in our FedRAMP cloud or in a hybrid fashion or on-premise itself. Any questions from the team? If not, I'll give a few minutes back to the folks from Confluence. All right, well, thank you very much. Sincerely appreciate everybody's time today. Bill, thank you very much. And if anyone has any questions, please contact Kirsten. We're happy to, for her to share our contact information and have more detailed discussions in any area that makes sense. So thanks, everybody.
Thanks.